All right, everyone, we're looking at set theory today. So I'm going to go ahead and get started with that, with some vocabulary. And of course, as I do this, I will be doing some examples and elaborate on these examples when we are in class, either through Zoom or perhaps face-to-face in the classroom. All right, so we're looking at set theory. A set, let's define that first. A set is basically a collection of objects. My pen is not writing too well today. Ooh, that's not good. So when we look at set theory, guys, the first thing we need to do is to look at definitions so you understand as we move forward the vocabulary usage. So a set, that's the first thing, is a set is a collection of objects. When we talk about a collection of objects, those things that are in the set, they're referred to as the elements, okay? The elements or the members of the set, okay? So basically, these are the objects in the set. So for example, if I were to tell you, I have this set of even numbers, 2, 4, 6, 8. There's a set of even numbers right there. So this set right here has a total of 4 elements. The 4 elements or the 4 members are 2, 4, 6, 8. So the objects in the set are the even numbers, and they're referred to as the elements or the members of the set. Now, in order to have a set, guys, okay, a set must be well defined. Let me write this down for you guys. Let me erase all of this so I can write it down for you. A set must be well defined, okay? Now, in order to have a well-defined set, you must give it a really good description where the contents must be clearly determined. So when we talk about a well-defined set, the contents, you must be able to clearly determine the contents of a set. For example, this last set I presented to you, I could say the set of even numbers less than 10, okay? Now, I could even go further. I'm going to define this term for you guys. I could say the set of even natural numbers less than 10. We'll talk about what a natural number is in a minute. So going back to the set from earlier, 2, 4, 6, 8, what do you notice about the set? All these are even numbers and they're all less than 10. So your set must be clearly defined. Now, when we talk about a set, guys, we usually use a capital letter to define a set. We use a capital letter to define a set. Now, when we're looking at a set, we can use any capital letters we want. Typically, though, you're going to see either A, B, C, and once in a while, you'll see this one. Later on, when we start talking about the Venn diagrams, U is another letter we use to define a set. And the U has specific purposes. In the case of defining a set, we refer to it as the universal set, okay? So for example, the set of even numbers, I could have said it's set A, and set A contains all even numbers less than 10. So set A would be equivalent to the set 2, which contains the elements 2, 4, 6, 8, okay? So there's your set right there. Now, I could even call it set E, and set E contains the even numbers all less than 10. So guys, it doesn't matter which letter you use, but typically when we talk about a set, we talk about it in terms of a capital letter. Now, how do we reference a set? To express a set, there are 3 ways to express a set. Now, let me go ahead and explain this to you guys first. 3 ways to express a set, okay? Let me talk about the set of natural numbers, okay? This capital letter N here stands for natural numbers. Natural numbers. What are natural numbers, you say? Natural numbers are those numbers you learn how to count with, okay? What numbers do you learn how to count with? The first number you learn how to count with is 1, not 0. So we're looking at 1, 2, 3, 4, 5, 6, and so forth and so on. By the way, those 3 little dots right there, they're referred to as the ellipses. Let me write this down for you. The ellipses. And when we talk about the ellipse, whenever you see it, it means that the set keeps going on and on and on. So if we had a set where we had 1, 2, 3, you know, skip a few, that's what the ellipse is there for, and you go all the way to 9 and then 10, this means that there's, you know what, let me put the set notation here because I want to make sure I'm using the right notation, okay? So that ellipse in the middle of 3 and 9 is saying that the set continues. We're skipping some of the numbers in the set, okay, between 1 and 10. So the ellipse would represent 4, 5, 6, 7, 8, okay? So whenever you see it, that just means that the set keeps going, or we're skipping a few, skip a few, okay? All right, so there are 3 ways to express a set. Number 1, you can use a word description. Use a word description. For example, earlier I mentioned that the sets of even numbers less than 10, okay? Here, let me write this down for you. The set of natural, now that you know the term, natural numbers less than 10. So that's one way to describe a set. Next, we can use number 2, set notation. And set notation is simply the braces, okay? Just the braces around the numbers. By the way, you cannot use the parentheses. No, no, no. You cannot use the square brackets. No, 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 to indicate set notation. You can only use the braces to indicate set notation. And then number 3, a third way to express a set is through set builder notation. You will see this throughout, but you can bypass saying set builder notation. Here's how it works, okay? So you need to identify the name of the set. When we talk about set builder notation, first you need to identify the name of the set, okay? For example, we could say set A is going to equal to all even numbers such that, you see there, right there, we want all the even numbers less than 10, okay? All the even numbers less than 10. So what is the difference between this and set builder notation? Here it is right there, okay? So we define the variables right here. Let me use a different color right there, okay? So we define the variable and we use the notation right here, such that, okay? So most of the time when we talk about a set, guys, it's probably option 2 we're going to use, in option 1, option 3. We talk about it, but we really don't refer to it as set builder notation, okay? So just so you know that if you see something expressed like this, that's what they're trying to convey to you. All right, now, next, we're gonna talk about the empty set. By the way, as we go through this, you will notice a lot of notation. So what I like doing after all of this is done is to go ahead and highlight all the different symbols you saw. So the empty set is next. And the empty set, guys, is also referred to as the null set. And obviously, since it's empty, it has no elements. And when we express the empty set, okay, it has no elements. When we express it, we can either use an empty set notation as such, or we can use a 0 with a slash through it. I'm sure most of you are familiar with this, comfortable with it, because this is the same notation we use for no solution, okay? So guys, that's some of the symbols that you are going to have to know. The empty set, what represents it, okay? And so now here comes the next one. The next one is talking about the membership. Membership, or part of a set, membership in a set. To show that an element is a member of a set, this is the symbol we use. And we refer to this as an element or a member of, okay? It shows that it's an element of. Now, if we want to say that it's not an element of, we're going to use the same symbol, but we're going to strike through it. We're going to draw a line through it. So this would say that it's not an element, all right? So what in the world am I talking about, right? So let me go ahead and show you guys what I'm talking about. So going back to my set of even numbers from earlier, 2, 4, 6, 8, all right? So on this one right here, even natural numbers, I got to put that in there too. If I wanted to convey that 4 is an element of the set, this is how I would convey it. I have the element, and then I would use my element symbol, and then here's my set right here, 2, 4, 6, 8. So when I read this as 4 is an element of 2, 4, 6, the set 2, 4, 6, 8, okay? Now, if I were to say this, on the other hand, 5, obviously, clearly, 5 is not a part of the even numbers. So I would go ahead and strike through that element notation to show that 5 is not an element of the set of even numbers, okay? Now, guys, be careful with the notation. Next thing I'm moving on are those inequalities, okay? Remember, this is just an overview. Why? Because I will be looking at more examples with you in the classroom. So I'm just giving you an overview here. We're looking at the inequalities, guys, the inequality symbols primarily, because we're going to reference them in terms of numbers, okay? So let's look. This symbol right here is greater than. I'm sure you guys know this already, but I'm just gonna go ahead and quickly go over it. Greater than. Then you have greater, let's go ahead and do the less than instead, okay? Less than. And then of course, if you see a line underneath, it is the same symbol as before, but because there's a line underneath, it's equal to as well. So greater than or equal to, I'm abbreviating here, okay? Less than or equal to. And then there's also this last one right here, not. You know, there's that strike through the equal sign, not equal to. So doesn't that make sense now that you know that strike through means not, okay? So we need to understand what the inequality symbols mean, okay? So now, guys, that same set I've been talking about. So here's another way we could express it. So I could say A is equal to, is the set of elements such that I want all natural numbers less than 10, okay? All natural numbers less than 10. Actually, I should just be writing it, but that's fine. All natural numbers, all natural even numbers less than 10. No, I need to rewrite this because that's not a good representation. Let me write it out, okay? All right, hold on a second. All even natural numbers less than 10. I could also do this instead. All even and then use the symbol for natural numbers less than 10. Okay, so now by expressing it this way, you know a natural number starts at 1, and the largest number you can get up to, in this case here, because you want all of them less than 10, it would have to be 2, 4, 6, 8. Now, if I were to change this to reflect all even natural numbers, okay, less than or equal to 10. Now that's different. Why? Because it's less than or equal to. Because it's less than or equal to, I can actually include the number 10 as part of the set. So guys, this is why you have to be so careful when you read this. You got to know what these notations mean. All right. So next part of this, okay, we have to count. Sometimes we need to count the number of elements in a set. So one of the questions you will be asked is to find the cardinal number of a set. Basically, when they ask you for the cardinality of a set, they're asking you how many elements are in the set. So how many elements are there in the set? Okay, my pen is not writing very well today. How many elements are in the set? Okay, so when we talk about the number of elements in the set, we use this notation right here. So let's say you were talking about set A, we'd use the N to represent number, and then of the name of the set inside the parentheses. So the number of elements in set A. For example, if I had set A here, it had the even numbers less than 10, 2, 4, 6, 8, okay? And I wanted to ask you, what's the cardinal number for the set? What's the cardinality of the set? You would say N of A is equal to 4 because there's 4 elements in the set, all right? So you need to know that term as well. Now, next, remember guys, this is mostly about terminology, definition, and yes, we will get into an example very shortly, okay? Equivalent sets. When we talk about equivalent sets, this means that it has the same number, 2 sets that have the same number of elements. All right, same number of elements, guys. So 2 sets containing the same number of elements, okay? So if I were to go ahead and give you something like this, okay? Set A has the elements 2, 4, 6, 8, okay? And set B has the elements A, E, I, O, because set A has 4 elements, set B also has 4 elements, they would be equivalent. On the other side, on the other hand, if we're talking about equal sets, that is completely different. When we talk about equal sets, okay, they have to have the same elements, guys, okay? They must contain the same element, which reminds me, when you write the elements in a set, they do not have to be in the same order, okay? So when we talk about an equal set, we're looking at 2 sets that have the same element. So in the case of set A and B, in the previous example, they are not equal. They are equivalent because they have the same number of elements, but they are not equal. So equal sets must have the same elements. So here's an example. Let's say A had the elements 2, 4, 6, 8, and B had the elements 8, 6, 4, 2. Because they have the exact same elements, we could say they're equal to each other, okay? So there's a difference between equivalent sets and equal sets, okay? Next, guys, we need to define the difference between a finite set and an infinite set. Okay, it's just like what it sounds. A finite set contains a definite number of elements, contains an exact number of elements. Okay, and so if this is an infinite set, though, when you talk about an infinite set, it doesn't, okay, does not contain a specific, that's an S right there, specific number of elements, which means it's basically continuous, guys. It just keeps going and going. So in other words, doesn't end. It doesn't end. So when you're looking at a set that's infinite, it means that it doesn't end. All right, so here's an example. The set that we've been talking about, the set of even numbers less than 10, that's a finite set because we know precisely how many elements we have in there. It has an exact number of elements. In that case, it would be 4 elements. But if I were to ask you for the set of natural numbers, okay, that one would be classified as an infinite set because the set of natural numbers keep going on and on and on forever and ever, okay? So there's a difference between a finite set and an infinite set. A finite set has an exact number of elements, so it ends. But an infinite set doesn't have an exact number of elements in it. It doesn't end. So finite ends, infinite doesn't. Does that make sense? I hope it does, okay? Because I know I'm throwing a whole lot at you. And it's a lot of terminology. But once again, I forgot to mention this, guys. This is the same information we covered in class. So basically, this is a review. So if you weren't clear on anything, I am just making sure that you're clear on these things as we move forward. Now, like I said, I am going to be doing examples with you guys when we meet up together. But I think what I want to do now is to just go ahead and let me see here. Should I run through a couple of examples with you guys? Okay, let me see. I think I should do the examples in class because that was basic information. So let me go ahead and move on to the next part. The next part, we'll spend some time going over examples, okay? So let me just add this next part and then we'll start on the examples. So this next part, guys, okay, we're going into more definitions, but it's not that much more, all right? So on this next part, since we've already defined what a set is, you know how to determine if you have an equivalent set, an equal set, a finite set, or an infinite set, okay? You know what the empty set notation looks like. By the way, the notations we looked at so far, guys, let me quickly recap on the notation because it was quite a few things, okay? When we talk about the empty set, okay, this is the symbol we used. Ooh, this is not writing for me. Okay, the empty set, we've got the braces for this, okay? This symbol right here represents an element of, okay? And then we've got this one right here, which is not an element of, not when you strike through it, okay? So whenever you see that strike through, like this one right here, that's the equal sign. You strike through it, that means it's not equal. And of course, you have the inequality symbols, greater than, less than, greater or equal to, less than or equal to, and all of those. And then of course, when you see N with the A in parentheses, it means the number of elements in a set, the cardinality of a set, the number of elements in a set. All right, guys. So now let's go ahead and move on to the last part of this so I can go ahead and do some examples with you guys. A subset. All right, we're defining what a subset is. All right. So when we talk about a subset, we're looking at a set where each of its elements belong to another set. All elements, this is all elements of a set belonging to or are members of another set. All right, so let me give you an example, guys. So we have A from earlier, where we said it's all the even numbers, okay? And it included 2, 4, 6, 8, all the even numbers less than 10, okay? Now, set B contains all the natural numbers, okay? All natural numbers. So one of the ways I could describe this when we talk about subsets is to say that A is a subset of B. A is a subset of set B. What does that mean? It means that all the elements which are in A, 2, 4, 6, 8, are also a part of the elements in set B. In that case, all the natural numbers. Remember, all the natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, keep going all the way down to infinity. So yes, set A is contained within set B. Now, just like before, here comes more notation, okay? So this notation right here, we use it to express that a set is a subset of another set. So one of the ways I could have said that A is a subset of B, or to express it, is to write it as A and then use the symbol subset of B. And there you are, okay? Yeah, I know, okay? So there's another symbol for you, all right? So now let's go ahead and move on to this, okay? So earlier we saw element and non-element of, same thing here, guys. We're gonna use the same symbol, okay? We're gonna strike through it. What does that mean? It means it's not. Whenever it's strike through, it means it's not, guys. You gotta remember that. It's not a subset, not a subset, all right? So if I were to have another set here, set C, and set C had the following elements, -2, -4. And I were to ask the question, is set C on a subset of set B? No, set C wouldn't be a subset of set B. So how do I express that? I would say C is not, with the strike through, a subset of B. Because, guys, obviously, when we talk about natural numbers, they're all positive, but set C has negative numbers in there. So there's no way set C can be a subset of set B. No way, okay? So those are most of the symbols we needed to talk about, guys. There's one last one I need to cover with you, so let me go ahead and clear this out, okay? By the way, the empty set, guys, the empty set, or in this case, you could use the set rotation right here, is a subset. All right. The empty set, you got to remember this one right here, okay? The empty set is always a subset, guys, okay? For any set, the empty set is always a subset. That's critically important. Why? Because later on, you're going to be asked to find the number of subsets in these sets. So the empty set is a subset of every set. Let me write this part down too. Is a subset of every set. All right. So now let's move on to this last symbol, and then we'll go ahead and talk about how we determine the number of subsets in a given set. All right, guys. So this last symbol right here is referred to as a proper subset. So first and foremost, you need to have a subset. In order to have a proper subset, you need to have a subset. Now, what differentiates a proper subset from a subset? Okay, here it is, guys. The number of elements in the subset must be less than the larger set. In other words, the number of elements in set A cannot equal to, ooh, you see that? To the number of elements in set B. So if set A is a subset of set B, the number of elements in set A must be less than the number of elements in set B in order for set A to be a proper subset, okay? So let's go back to another example. One of the examples I gave you was that set A had the elements 2, 4, 6, 8, and I told you set B had the elements, all the natural numbers, okay, as elements. So if I give you set B is all the natural numbers and set A contains the elements 2, 4, 6, 8, and I ask you the question, is set A subset, a proper subset, or not a subset of B? Okay, so here are your choices. Subset, proper subset, not a subset, or could it be both subset and proper subset, okay? So in this case here, guys, because all the elements in A are contained in set B, not only is set A a subset of set B, but set A is also a proper subset of set B. Now, why? Number one reason, the number of elements in set A are less than the number of elements in set B. So there you go. Now, if you're confused by proper subset and subset, okay, let me explain it to you this way, okay? So when we talk about this symbol right here, okay, think of it as the inequality symbol, less than, all right? When we talk about this one right here, think of it as the inequality symbol, less than or equal to. Shazam. So guys, if the two sets were equal to each other, they wouldn't be proper subset. So hopefully this helps right there. I hope it helps, okay? So now I am going to talk about how we determine the number of elements, the number of subsets, okay? To determine, to find the number of elements, I mean the number of subsets, Shazam. Okay, that phone distracted me. The number of subsets in a set. We use the formula, guys, 2 to the n to calculate the number of subsets. 2 to the n. Now, what does that mean? It means this, guys, when you're given a set, you can create a whole bunch of subsets from that given set. And keep in mind, the empty set is a subset of every single set too. So if I were to give you this set right here, and I were to ask you, how many subsets does it have? And I'm using a small set here because I need to make the point here. One of the sets would be the empty set. That's one of them. Okay, the empty set. Then we've got the empty set and then plus a number 2. So that's 2 subsets. Then we've got the empty set with the number 4. Then we've got all the elements inside the set, the 4, the 2 and the 4, and then plus we have the empty set. So altogether, how many do we have? We have 1, 2, 3, 4. Now, let's verify this. If we're going to use the formula 2 raised to the n power to calculate the number of elements, by the way, n is referenced as the number of elements in the set. So if we're going to find the number of subsets, we use the formula 2 to the n. So to verify this one, guys, it has 2 elements, 1, 2. So to calculate how many subsets it has, we're going to do 2 to the second power. Where am I getting that 2 power from? Because there's 2 elements inside the set. And I'm going to calculate this. How do I calculate it? It's 2 to the second power. 2 multiplied by itself. So 2 times 2 gives me 4. So that's a total of 4 subsets, okay? Now, additionally, to calculate the number of proper subsets, remember, when we talk about these proper subsets, the number of elements in a proper subset must be less than the original set, okay? So the number of subsets in a proper subset, we use the formula 2 to the n minus 1 to calculate how many proper subset the set would contain. So in the case of this example right here, there's a total of 4 subsets. So if we ask for the number of proper subset, this one would only therefore contain how many? Just 3, because it's 2 to the n minus 1. Okay, 2 to the n was 4. So if you subtract 1 from that, that leaves you with 3, guys. Now, that was a whole lot, okay? So let me quickly do an example for you, okay? So all the sets, all the natural numbers, all natural numbers between 6 and 12 with 12 included. All right, guys. So if I wanted to express this, all the natural numbers from 6 to 12 and 12 is included, the set would be something like this. Okay, so 6, 7, 8, 9, 10, 11, 12. I have to include the 12. Now, if I wanted to express this and using an inequality, would be n is less than or equal to 12, but greater than 6, okay? Greater than or equal to, let me see, all the natural numbers between 6 and, oh, I included the 6, Shazam. Okay, let me get rid of that 6, guys. Did you see that? I included the 6. Okay, the 6 is not included. All right, so all the natural numbers between 6 and 12, 12 is included. So if I'm writing this as an inequality, this is, oops, this is how it would be expressed as an inequality right there. Let me use this. There we go. That's the inequality for it. And when I write out the set of numbers between 6 and 12 with the 12 included, okay, and I did not write all of that out with 12 included, okay? So this is what the set would look like. Now, okay, let's take it a step further. I could ask you a question like this, true or false, okay? 7 is an element of, oops, 7, 8, 9, 10, 11, 12. True or false? That one would be true. But if I were to say 6 is an element of 7, 11, 12. Okay, this one right here would be false because 6 is not an element of it. All right, so then the next thing I could ask you is, how many elements are in set A? The number of elements in the set, just count them out. So you got 1, 2, 3, 4, 5, 6 of them. Okay, there's 6 of them in the set. All right. And then the other question I could also ask you is this. Ooh, I cleared out everything, guys, okay? So I could say set A has the elements. Oops, oh my goodness. Okay, there we go. Set A has the elements 8, 10, 12. Set B has the elements 7, 8, 9, 10, 11, 12. Okay. A is blank B. And you have to choose from subset, proper subset, okay, or not a subset, okay? So in the case of this one, yes, set A would be a subset because 8, 10, 12 are included in set B, and would also be a proper subset. Now, on the other hand, if I were to go ahead and let's say I put a 6 in here, okay, then set A would not be a subset of set B because of that 6 in there, okay? So in order for A to be a subset of B, all the elements in A must belong in set B. So if A includes the number 6 and 6 is not in set B, it cannot be a subset of set B. All right. So now here's the other thing I could ask you. Let me take out that 6 out of there, okay? I could ask you, what's the number of elements in set A? You would tell me 4. What's the number of elements in set B? You would tell me 6, okay? Now, here's the next part. I could ask you, how many subsets does set A have? Subsets of set A. To calculate the number of subsets of set A, we would go ahead and take 2 and raise it to the number of elements in set A, which in this case is 4. So we'd multiply 2 times 2 times 2 because it's 2 to the 4th power, 2 multiplied by itself 4 times, and that would give us 16. Now, if I were to ask you for set B, and for set B, we would do 2 to the 6th power. So you multiply 2 by itself 6 times, guys, okay? And that one would give you 64, all right? 64 subsets in set B, 16 subsets in set A. Now, if I were to ask you the number of proper subsets in set A, you would do 2 to the n minus 1. So if it's 2 to the n minus 1, set A had 16 elements, so it would have 15 proper subsets, which means you would do 2 to the n minus 1. It's got 4 elements in here, 2 to the 4th minus 1, and you calculate that. 2 to the 4th is 16 minus 1, that would give you 16. And for set B, it had a total of 64 subsets. So now you would do 64 minus 1, which gives you 63 subsets. I know it's a lot of information to take in, guys, but this requires practice for you to get used to it. And the terminology is critical because you need to understand what the problem is asking you to find. So hope this helps. And I'm going to go ahead and stop this video right here, guys.